Hello friends, this video on inverse trigonometric functions part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study inverse trigonometric functions and properties of inverse trigonometric functions. Before we study inverse trigonometric functions, let's understand why do we need to study inverse trigonometric function. What is the practical application of inverse trigonometric function? What will happen if we don't study inverse trigonometric function? So we'll study here what is the application of inverse trigonometric functions in day-to-day life. If you see this, in the world of science and technologies, we do use inverse trigonometric functions a lot of time. For example, you want to find the angle the star makes with the place, find in the molecular structure the angles which these molecules make. For such things, we need inverse trigonometric function. If we don't know inverse trigonometric functions, we won't be able to deal with such scenarios in terms of science and technologies. Also, if you're an architect and you're building some monuments or buildings, in that case also, you need inverse trigonometric functions. For example, you want to find the angle which this should bend, or this angle or this angle. So for such thing, we need inverse trigonometric functions. So if you're an architect or if you are in the field of science, inverse trigonometric function is a must for you. Before we start with inverse trigonometric function, let's see the dilemma. And that is the dilemma which is the foundation for this whole chapter. The dilemma is like this. We know that for inverse to exist, the function must be 1 over 1 and onto. If you don't know this, please watch the previous chapter videos. In this chapter, we have explained why the function should be 1 over 1 and onto for an inverse to exist. So the statement we know is for inverse to exist, function must be 1 over 1 and onto. If you don't know, watch the earlier chapter. If you know, we can proceed with the next line. But we know that the trigonometric functions, they are neither 1 over 1 nor onto. On their natural domain, please note, on their natural domain and range, they are neither 1 over 1 nor onto. But we have to find inverse trigonometric function. How can we do? We can't do. We have to write something, do something we have to do to make sure that trigonometric function is 1 over 1 and onto. Why we want to move that? Because we want to find inverse trigonometric function. You got dilemma, right? The dilemma is for an inverse to exist, the function has to be 1 over 1 and onto. But we are saying that trigonometric functions are neither 1 over 1 nor onto. But still we want to find inverse trigonometric function. So if you see this, what I'm trying to say is, for example, this is sin x graph. We know that sin pi is 0. In fact, sin 0 is also 0. Sin minus pi is also 0. It's minus pi side. So if you make this graph like this, there are values like 0, pi, minus pi, 2 pi. All these will give you value 0. Correct? So, and if you see, there are so many values like pi by 2, this just gives 1. So there are so many, plus if you see minus pi by 2, so 5 pi by 2, this will also give 1. So if you see, this is not 1 over 1. Why? Because for one value, there are so many injections. So it is not 1 over 1. Also, it is not onto. Why? Because the sine value, if you see, the maximum value is 1, the minimum is minus 1. So 1 to minus 1 is the range for this. There are so many values like 4, 5, 6. If I'm talking about R to R, domain and range, in that case, if you see, these values are all orphan. Because the natural domain is nothing but R to R. So if you see in this natural domain and range, it is neither 1 over 1 nor onto. And we want to find inverse of this function. which we can't do now because it is not 101. It is neither 101 nor onto. So what should we do? We should restrict these domain and range. If we restrict this domain and range, then only we can make this trigonometric function as inverse. We can find the inverse of trigonometric function if and only if we restrict what? Restrict domain and range. So if we restrict domain and range, what we'll do? We will make this function 101 and onto. We'll explain all these things. We'll take some examples, sine, cos or tan. We'll take some examples to do that. Just try to understand this, why we are doing it. For a function, for an inverse to exist for a function, the function has to be 101 and onto. But we know that for trigonometric function, they are neither 101 nor onto on their natural domain and range. We saw this. There are some extra values and so many values pointing to 0. So it is not 101 nor onto. But we want to make it inversible because we want to find inverse trigonometric function. To do that, what we are doing is we will restrict this domain and will restrict this range. And thus we'll make the function 101 and onto. Let's see. The same thing which I told, will restrict domain and range to make sure that the inverse exists. So in this case, if you see, if you restrict to this value, from here, for example, from here to here, if you see, it goes to 0, from 1, and it goes to again 0. And then I have some negative values also, so I'll take these, or better let me take this half. So in this half you see all the values which I am getting in the y-axis are unique values. So if my domain is this and my range is -1 to 1, in that case I am getting invertible function. In that case it will be a 1, 1 and onto function. Let's explain this. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.